Welcome to the viewers for the lecture on the topic construction of frames. Thank you for your continued support in spite of number of breaks. Once I have stopped 3 years back, and then I given some lectures, and after a very long break I given lecture number 171 and 172, but your support continues. Thank you all for your support. And I have delivered lectures 171 and 172 on construction in Tamil. I understand, and also one of the viewers have commented, why not in English? Therefore, lecture number 173 will be in English. I understand that the viewers prefer English communication. Now, in this lecture number 173, I will try to deliver some points on construction of building frames. Actually, there are two types of structures. Basically, one is a load bearing structure, the other one is a framed structure. In the case of load bearing structure, there will be no columns or beams. Beams will be there, but the load transfer will be only through the walls. So walls will receive the load and transfer to the foundation, and the foundation will be provided over the entire length of the wall. But in the case of framed structures will be consisting of a system of beams, columns, foundations, etc. Whatever may be the load that is coming on the structure, wall load, whatever load we have, the loads will be transferred to the soil through the frame in a systematic manner. That is, the walls will, the roof slab will transfer the load to the beams will transfer the load to the columns will transfer the load to the foundation, and foundation will transfer the load to the soil. That is, load not only roof slab, all slabs, from slab to beams to columns to foundation, and foundation to soil. That is, in this figure you can understand, yes, this is a frame, this is a simple frame. Now here, this is the load that is transferred from the roof slab. This is the load transferred from the floor slab. The load from the slab will be transferred to the beams acting as the supports. So this beam, half the load will, depending upon the span, half the load will be transferred to this column, another half will be transferred to this column. From this beam, half the load will transfer to this column, and half the load will be transferred to this column. So, from the slab to the beam to column to foundation to soil. This is the load transfer mechanism. Whatever may be the load, through this system, the load will be transferred to the soil. So, the structure will have to be as strong as possible. So here, in the construction of the frame, as we have discussed in one of the previous lectures, the following points are to be controlled, very carefully controlled. One is that of the water cement ratio. Water cement ratio will have to be maintained at the designed level. Concrete mix is to be proper. Majority of structures, it is proper. But in some of the structures, when the work is done by inexperienced masons, sometimes the mixing will not be proper. So they will, as I told earlier, they will spread one layer of coarse aggregate, then one layer of fine aggregate, that will remain for some time. Then they will add cement on the top, add some water and mix it. Even in the mixer driver, water cement ratio is not controlled. So the mix is to be proper, concrete mix is to be very proper and perfect. And also the compaction of concrete by needle vibrator or some vibrator, compaction is another very important point. And then after the completion, curing is another important point. The concrete will have to be cured, not only concrete, also masonry will be allowed to be cured to the required number of days through continuous watering. These are very important points to be followed in the case of concrete. Right. Now coming to the points, now this is the plinth beam. The plinth beam should not be directly constructed on the soil. So you have to go for one layer of PCC, plain cement concrete, on which you can do the plinth beam construction, or one layer of masonry on which you have to provide the plinth beam. That is one important point, not directly on the soil. And we have discussed the load transfer mechanism, that is over. Then regarding the construction, actually the procedure is the entire frame is to be constructed. The entire frame is to be constructed. Then only the walls are to be, entire frame, columns, beams, everything will have to be constructed completely. They have to be cured for the required curing period, and then only you have to start the construction. Now construction will have to be started from the topmost floor. Topmost floor you have to do the construction. Before telling you that point, suppose if we construct the some people may follow that they may construct the wall up to the bottom of the beam. They will use the top of the wall as the centering for the beam above. This wall, the top of the wall will be used as the bottom centering. They will not provide centering. The beam will be cast on the wall. So that should not be done. So because the walls are meant for only filler walls, they are going to act only as the filler wall, because they are not supposed to take the load from the beam. If the top of the wall is used for centering purpose, then there is a great possibility that part of the load will get transferred to the wall, below which it will be transferred to the plinth beam. Then there is no foundation here. So the load must be necessarily transferred to the columns only. Therefore, the top of the wall should not be used as the bottom centering for the beam. Similarly, sometimes they will do the wall, and one side of the wall will be used as the centering for the column. That also should not be done. Therefore, that is why I told complete frame is to be constructed, then only the wall construction will have to be started. So this is about the top of the wall should not be used to form the bottom centering of the beam. That is another point. Then the walls will have to be started from the topmost floor. The reason is, if the topmost floor is constructed, these gaps are filled with walls, then due to the weight of these walls, this beam will slightly bend. There will be a little deflection. There will be a little deflection. Now here these are empty now. Therefore, this can freely undergo the deflection, after which we can go for the construction of the next floor, construction of wall in the bottom floor. Then after deflection of these two beams, then we can go for construction of these things, so that when the beam gets sufficient deflection or bending, after which when you construct these two walls, the load from this beam, because of its bending, will not be transferred to this wall, and that again will not be transferred to this beam. So the load will directly go to the columns only. The purpose of the construction of the frame will be served, right? Sometimes the contractor or the builder may not be interested in wasting the time of the workers, the masons, etc. They may try to utilize the available worker force. That is not wrong if that is done. What we can do is, only thing is, before the construction we have to see that these columns are cured for sufficient number of days, after which you can go for this construction. But when the construction is to be started from the bottommost floor, what we have to do is, we have to initially give one gap at the top. It should not, the construction should not be up to the top, up to the bottom of the beam. It should not be. So there should be a gap here. This gap can be filled at the end. Initially, it has to be left as a gap. Similarly, when you do the first floor construction, here also you have to give one layer gap. Then you can go for the construction of the top floor. After the construction of the top floor, again there will be a deflection. So these two beams will undergo deflection, bending and deflection. So there will be a slight settlement, slight bending. So since there is a gap, we are just leaving one layer on the top, so that when the beam slightly bends, the load from this wall and from this beam will not be transferred to the masonry or wall below, because you got a gap. After that, if this gap is filled with masonry, there will be no further settlement. Similarly, for the construction of the bottom floor also, after completing these two walls and after getting the required deflection, there will be a slight bending and a deflection. After that, if this gap is filled, then there will be no problem. Otherwise, when this is initially constructed up to the bottom of the beam, due to this bending, the load transfer will be there on the wall, and this wall will transfer the load to the plinth beam. There will be a bending, and there is no foundation below. The load transfer is only from slab to beam, beam to column, column to foundation. That is, then only the purpose will be completely served. The frame will not be having any problem. And in all these cases, because in the cities there will be skeletal of a structure, that is, it will be simply consisting of slabs, columns, beams and foundation, no wall anywhere. So that will be there, and we will be able to witness this frame in a number of places in the city, in the construction. After sufficient curing and after sufficient strengthening only, they will go for the wall construction. Wall construction will not be started from the top. If it is from the bottom, this care is to be taken. So after completion of the frame, the wall is to be constructed. Then when you do the construction like that, this column and the beam are of concrete. This wall is of masonry. Even in this wall, if you construct this from the bottom, you will be leaving a gap. This gap will be filled at the end. Therefore, when there is shrinkage, because this is of a different material, this is of a different material. The construction of period of this is different. The construction period of this is different. Therefore, there is a possibility of shrinkage crack between this beam and the top layer. Also, there is a possibility of shrinkage crack between this column and that of the masonry. So, here there must be a clear understanding, a perfect understanding between the builder or the owner and the contractor, because the owner should not mistake that this is a crack and this is a crack, and should not penalize the builder or the contractor. It will be there. Suppose if this gap is not given, then construct the ground floor, first floor, second floor in the reverse order, then there will be vertical cracks. When this is loaded, when the load is transferred from this wall to this beam to this wall, this beam to this wall, etc., then there is a chance for cracks, vertical cracks in the wall. Then that is not correct. But the shrinkage cracks between the beam and the wall and the column should not be treated as a crack. So there must be a perfect understanding so that the builder will confidently proceed with the construction. Also, in some of the designs, the builders or the owner will require design in a short period. So they will take 15 years or 20 years to save money for the construction. They will take 1 month or 2 months for planning the house. After planning everything, they want the plan and the design in 1 or 2 days. Design is a very important point which will require, depending upon the building, it will require 5 to 6 working days. 5 to 6 working days. Because why I am saying this is, even some 3 days back, I got a design. You know that I am working as a structural consultant. I got a design from some outside place. They wanted the design in 1 day. Morning they will give, evening I have to give the design. I said, no, that is not possible. And people are there to take it. That is why they are able to achieve. But it is possible. It is possible because some people, without designing anything, they will give some standard dimension, standard reinforcements. 10 feet, 12 feet, 16 feet means this is the size of the beam, this is the reinforcement. 2 floors means this is the load, 3 floors this is the load, like that. They have some standard value and give the design. That is not always correct, because in the structure, suppose if there is a beam here, let us say the length of this beam is actually 12 plus 5, 17, 18 feet, 17 or 18 feet, say, we can say 18 feet. If it is a normal beam, 18 feet, you can give the dimensions and reinforcement, and you can, yes, it is possible. But there is a beam from here, this will transfer load on this beam. For that, the standard design will not work. Similarly, for this, we have a beam here. And here you are supposed to have a beam. This beam is eliminated because inside the room the clients may not like to have a beam. There is no beam. So the load transfer will be slightly different. And here there is a beam, but there is no column. So here again there is no column. But this beam will transfer load to this beam. There will be load transfer. So if for this beam, if standard dimensions and the standard bars are given, that will not work. Therefore, when we eliminate some intermediate beams or intermediate columns, that will be that the standard dimensions will not work. But still, it is happening. I do not want to say anything on that point. People are not patient to give 1 week time for design. That is the problem. Morning they want to give, evening they want the design. So that is not good. And also, if the standard structural design and the structural drawings are available, the importance of this already I have discussed in lecture number 172 also. The builder or the mason, whoever has got the drawing of the designed structure, they will find it very convenient, because the connection here, this beam and this beam are to be connected. The connection, how the beams are to be connected, what reinforcements are to be provided, all these things will be clear in the drawing. Here, similarly, here there is a beam, here there is a beam. How to connect these two beams, whether the tops are to be at the same level or the bottoms are to be at the same level, all these things will be in the drawing after proper design. So the construction will be easy, execution will be easier, and also the builder as well as the owner will be happy to execute the work without any confusion. Also, when the design is done, there is a possibility that the column size towards the upper floor can be reduced. If the size of the column in the bottom floor, ground floor, is 9 inches by 18 inches, the same in the first floor can be 9 inches by 15 inches. In the second floor, it can be 9 inches by 12 inches. In the fourth floor, it can be 9 inches by 9 inches. That can be reduced. However, for 2 or 3 floors, this is not practiced, because going on changing the column and you are going to fill that with masonry. See, for 3 inches in each floor, changing the dimension of the centering sheet and providing extra masonry work will not give much saving. Therefore, ground floor, first floor, second floor means it is customary to go for the same size of the column. Otherwise, we can go for reduction in the design. But if it is consisting of 6 floors, 7 floors, 8 floors like that, for the ground floor, first floor, second floor, adopt one size of the column. In the third floor, there will be considerable reduction in the size of the column. There, you can go for reduction in the size of the column and increasing the masonry work. So this is possible if structural design is carried out. If it is not, you have to go for standard dimensions and standard reinforcements. And generally people complained that the reinforcement given is heavy. See, please remember, particularly young designers and students leaving the college, this will be very useful. People will claim that you have given more reinforcement. See, those who have studied structural engineering will know that we will normally go for under reinforced section only, because if you provide more reinforcement, the failure will be sudden, brittle failure. It will not give any indication. Therefore, we will never go for over reinforced design. So you have to satisfy the client, you have to satisfy the owner that we will never go for over reinforcement. We always design only under reinforced sections. Under reinforced section means we will provide reinforcement little less than what is required for a balanced section. When we design the structure as a under reinforced one, if at all if there is any failure, it will indicate. there will be a slight deflection, slight removal of the plaster, slight removal of patches, slight deflection. It will indicate that it is going to fail, but suddenly it will not fail. You will have enough warning, you will be able to safely make arrangement. If at all, if it is needed, you can comfortably vacate. Therefore, always structural engineers will design the structure only as under reinforced section. They will never design the structure as over reinforced section. This is another important point, that is because we have designed many structures. In some of the structures, after seeing the lintel reinforcement, some 2 clients from some other districts, some 2 clients, they said, we don't want the lintel drawings, because they will adopt their own reinforcement. So in the structural drawing set itself, we have eliminated the issue of structural drawing for the lintels. So they particularly want to eliminate some of the designs, and after the design, some of the clients, after seeing the reinforcement for the foundation, they have refused to take the design. And these are all happening. We provide only under reinforced section. This I want to strengthen. And one more point here is, always we will not design the structure as earthquake resistant structure, because designing completely earthquake resistant structure may not be affordable to all the customers. It will be very costly. However, we can go for nominal reinforcement to take care of small earthquakes. Nominal reinforcement means in the design itself we will give the drawing. Suppose if the column, if it is the column, 1/4 height of the column at the top, 1/4 height of the column at the bottom, we provide the lateral ties at closer spacing, and in the middle half we provide the actual reinforcement. So this is to take care of the earthquake. Similarly, in the case of beams, 1/4 span at the left end, 1/4 span at the right end, we provide the stirrups at the closer spacing, and in between the middle half the span we will provide in the normal required spacing. So these are all some minimum reinforcement to, if at all if there is an earthquake, this will take care of the earthquake forces to some extent. So that's about some of the points regarding the construction of the frame. See, one side of the column, this is the masonry. This wall should not be used as centering for this column. This is the column, this reinforcement may be available. So this wall, the end of this wall and the end of this wall should not be used as centering for the column for 2 sides. The columns and the beams are to be completely concreted. The frame is to be completely erected. It has to be sufficiently cured, and then the wall is to be constructed. The wall construction also preferably from the topmost floor, because if the topmost floor, if the construction is done, there will be slight bending and slight deflection. Only when this is free, this space is free from the wall, this will have the required amount of deflection. The load will not be transferred to this wall and again to this beam and then to the next wall, because these walls are not meant for taking loads. There can be a slight deflection, but the load transfer is only to the columns and not to the walls. So these are some of the points we have discussed. All the required, the construction will be started from the top and go towards the bottom, and if it is necessary to be started from the bottom, this gap we have to keep in mind, and the cracks, shrinkage cracks at the top. So there must be clear understanding between the owner and the builder, etc. owner and the builder. And these are some of the points that are to be taken care in the construction of frames. So, if at all if there is any missing point, we will take it up in the next lecture. So, thank you for your patient hearing. Thank you all, dear viewers. Thank you.